Chapter 14. Congruence of Triangles. Introduction. In previous chapters, we have learnt about triangles and their various properties. Now we will learn about congruence of triangles. Congruence. Every figure has a shape and size. By simply looking at the two figures, we can decide whether they have same shape or not. To decide whether they are of the same size, we put one figure over the other. If they cover each other exactly, then the figures are of the same size and same shape. Two geometrical figures are said to be congruent if they are exactly of the same shape and size. The relation of two objects being congruent is called congruence. Such figures can be superimposed on the other to cover it exactly. For example, two photographs of the same size from the same negative are congruent. If a 5-rupee coin is placed over another 5-rupee coin of the same year, they cover each other exactly. The word congruence is represented by the symbol and read as is congruent to. Thus, if there are two figures, A1 and A2, then A1 congruent to A2 means that figure A1 is congruent to figure A2. Congruence of line segments. Two line segments are congruent if they have the same length. Let AB and CD be two line segments. We take the trace copy of AB and superimpose it on the line segment CD. If C coincides with A and B with D, then AB and CD have same length. Hence, two line segments AB and CD are congruent and written as AB congruent to CD. Conversely, if two line segments are congruent, they have the same length. Congruence of angles. Two angles are congruent if they have equal measure. Consider two angles, angle ABC and angle DEF. We take a trace copy of angle DEF and superimpose it on angle ABC such that E falls on B and ray EF falls on ray BC. If ray ED falls along ray BA, then angle DEF covers angle ABC exactly, and we say that two angles are congruent. Thus, if angle ABC congruent to angle DEF, then angle ABC is equal to angle DEF. Congruence of squares. Two squares are congruent, that is, same in shape and size, if each, when superimposed on the other, covers it exactly. Since all the squares have the same shape and the size of a square is determined by the length of its side, two squares are congruent if they have the same side length. Thus, square ABCD is congruent to square PQRS if AB is equal to PQ. Congruence of rectangles. Two rectangles are congruent if their lengths and breadths are same. Consider two rectangles ABCD and PQRS. We take a trace copy of rectangle ABCD and superimpose on rectangle PQRS. We find that it will cover rectangle PQRS exactly if AD is equal to PS and CD is equal to RS. Thus, rectangle ABCD is congruent to rectangle PQRS if AD is equal to PS and CD is equal to RS. The same can be verified by superimposing rectangles on each other. Congruence of circles. We know that all circles have the same shape and the size of a circle is determined by its radius. To find out whether two circles C1 and C2 are congruent or not, we take the trace copy of one of the two circles, say C1, and try to make it cover the second circle C2. If they are of the same radius, the circles will cover each other exactly. Thus, circle C1 is congruent to circle C2 if they have the same radii. Two triangles are congruent if and only if one of them can be made to superpose on the other, so as to cover it exactly. There are 6 elements of a triangle which decide the shape and size of the triangle. Let us consider two triangles, triangle ABC and triangle PQR, where angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R, AB is equal to PQ. BC is equal to QR. AC is equal to PR. Take one of the triangles, say triangle ABC. Trace it on a paper and cut it along its boundary. Now, superpose this cut-out triangle on triangle PQR by placing vertex A on P, side AB on PQ, and side BC on QR. We observe that two triangles coincide with each other. Hence, two triangles are congruent. If, under a given correspondence, two triangles are congruent, then their corresponding parts, that is, angles and sides, that match one another are equal. Thus we have corresponding vertices A and B, B and Q, C and R, corresponding sides AB and PQ, BC and QR, AC and PR, corresponding angles, angle A and angle P, angle B and angle Q, angle C and angle R. For congruence, we have to match the corresponding vertices of triangle ABC and triangle PQR. A correspondence P, B correspondence Q, C correspondence R. This is called correspondence between two vertices of triangles. It can also be written as ABC correspondence PQR. It also means AB correspondence PQ, BC correspondence QR, and AC correspondence PR. To prove congruence of two triangles, it is sufficient to match three particular elements to be equal. Example: triangle ABC and triangle XYZ are congruent. Under the correspondence ABC correspondence XYZ, write the parts of triangle ABC that correspond to XY, angle Y, XZ. Solution: the correspondence triangle ABC correspondence triangle XYZ, A correspondence X, B correspondence Y, and C correspondence Z. XY correspondence AB, angle Y correspondence angle B, XZ correspondence AC. Criteria, conditions for congruence of triangles. If we have two triangles and want to verify whether they are congruent or not, it is a tedious process to cut one of them and superimpose one over the other. There are 4 conditions to verify congruence of triangles. Side, side, side. SSS, congruence condition. Two triangles are said to be congruent if 3 sides of one triangle are equal to the 3 corresponding sides of another triangle. Let us consider two triangles, triangle ABC and triangle PQR, where AB is equal to 5 cm, BC is equal to 4.5 cm, AC is equal to 3.5 cm, PQ is equal to 5 cm, QR is equal to 4.5 cm, and PR is equal to 3.5 cm. We measure all the angles of these two triangles. We observe that angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. Two triangles have equal sides. Then their corresponding angles are also equal. So, all 6 elements of triangles are equal. Hence, two triangles, triangle ABC is congruent to triangle PQR. This is called SSS congruence rule. Example 1. In the adjoining figure, it is given that AB is equal to CD and AD is equal to BC. Prove that triangle ADC is congruent to triangle CBA. Solution: in triangle ADC and triangle ABC, AD is equal to BC given. CD is equal to AB given. Side AC is common. Therefore, triangle ADC is congruent to triangle CBA. Example 2. In triangle PRQ and triangle PSQ, PR is equal to PS and RQ is equal to SQ. Prove that triangle PRQ is congruent to triangle PSQ. Solution: in triangle PRQ and triangle PSQ, PR is equal to PS given. RQ is equal to SQ given. PQ is common. Hence, Triangle PRQ is congruent to triangle PSQ. Side angle side SAS congruence condition. If two sides and the included angle of one triangle are equal to the corresponding two sides and the included angle of another triangle, then the two triangles are congruent. In short, this condition is written as SAS, side angle side. To verify above condition for congruence, let us construct two triangles ABC and PQR, where AB is equal to PQ, which is equal to 4 cm. BC is equal to QR, which is equal to 3.5 cm. And angle B is equal to angle Q, which is equal to 60 degrees. Now we measure the angles, angle A, angle P, angle C, angle R, and sides AC and PR. We observe that angle A is equal to angle P, angle C is equal to angle R, and AC is equal to PR. Hence, all 6 elements, 3 sides and 3 angles are equal. Example: in the given figure, PS and QR intersects at O, and OP is equal to OS. OQ is equal to OR. Show that triangle POQ is congruent to triangle SOR. Write equal pairs of angles. Is PQ parallel to RS? Solution: in the triangle OPQ and triangle OSR, OP is equal to OS given. OQ is equal to OR given. Angle POQ is equal to angle SOR, vertically opposite angles. Hence, triangle POQ is congruent to triangle SOR by SAS congruence rule. Since triangle POQ is congruent to triangle SOR, therefore, angle POQ is equal to angle SOR. Angle OQP is equal to angle ORS. Angle OPQ is equal to angle OSR. PQ and RS are two line segment. PS is a transversal intersecting them. Angle OPQ is equal to angle OSR, alternate angles. This implies PQ parallel to RS. Angle side angle, ASA congruence condition. Two triangles are congruent if the two angles and the included side of one triangle are respectively equal to the two angles and the included side of the other triangle. Let us construct two triangles as shown above. In triangle ABC, angle A is equal to 50 degrees, AB is equal to 4 cm, and angle B is equal to 60 degrees. Another triangle, PQR, where PQ equal to 4 cm, angle P equal to 50 degrees, angle Q equal to 60 degrees. We make a copy of triangle ABC on a tracing paper and superpose on triangle PQR with A on P, B on Q, and C on R. We observe that the two triangles cover each other exactly. Hence, if two angles and included side of one triangle are equal to two angles and included side of another triangle, then both the triangles are congruent. Remark: if two angles of one triangle are equal to two angles of another triangle, then third angle of both the triangles will be equal as the sum of angles of a triangle is 180 degrees. The condition ASA for congruence is also true for SAS or SSS. Example 1. In quadrilateral ABCD, angle BAC is equal to 50 degrees. Angle BCA is equal to 25 degrees. Angle DAC is equal to 25 degrees. And angle DCA is equal to 50 degrees. Is triangle ABC congruent to triangle CDA? Give reasons. Solution: in triangle ABC and triangle CDA, angle BAC is equal to angle DCA given. AC is common. Angle BCA is equal to angle DAC given. Hence, triangle ABC is congruent to triangle CDA by ASA congruence rule. Example 2. AD is the bisector of angle A such that AD perpendicular to BC. Is triangle ABC an isosceles triangle? Give reasons in support of your answer. Solution: in triangle BAD and triangle CAD, angle BAD is equal to angle CAD. AD is bisector of angle A. AD is common. Angle ADB is equal to angle ADC, which is equal to 90 degree. Therefore, triangle BAD is congruent to triangle CAD by ASA congruence rule. Therefore, AB is equal to AC, corresponding sides of congruent triangles. Hence, triangle ABC is an isosceles triangle. Right angle hypotenuse and side RHS condition. If the hypotenuse and one side of a right-angled triangle are equal to hypotenuse and corresponding side of another right-angled triangle, then the two triangles are said to be congruent. This is known as RHS condition for congruence of triangles. Let us draw two right-angled triangle ABC and triangle PRQ. In triangle ABC, where angle B is equal to 90 degree, AC is equal to 5 cm and BC is equal to 4 cm. And in triangle PQR, where angle Q is equal to 90 degree, PR is equal to 5 cm, QR is equal to 4 cm. We observe that on measuring other angles and sides, angle A equal to angle P, angle C equal to angle R, and AB equal to PQ. Thus, all the 6 elements of one triangle are equal to the corresponding 6 elements of other triangle. Hence, triangle ABC is congruent to triangle PQR. Example 1. In the figure, PS perpendicular to SR and PQ perpendicular to QR. Also, SR is equal to QR. Show that triangle PSR is congruent to triangle PQR. PQ is equal to PS. Solution. In triangle PSR and PQR, angle PSR is equal to angle PQR, which is equal to 90 degree, given PR is common. SR is equal to QR, given triangle PSR is congruent to triangle PQR by RHS congruence rule. Hence, PS is equal to PQ, corresponding sides of congruent triangles. Example 2. In triangle ABC, AB equal to AC and AD perpendicular to BC. Prove that D is midpoint of BC. Solution. Given triangle ABC, where AB equal to AC, AD perpendicular to BC. In triangle ADB and triangle ADC, angle ADB equal to angle ADC, which is equal to 90 degree, given hypotenuse AB equal to hypotenuse AC, given side AD is common. Therefore, triangle ADB is congruent to triangle ADC by RHS congruence rule. BD equal to CD, corresponding sides of congruent triangles. Hence, D is midpoint of BC.